Alright, let's look at the Bernoulli substitution or Bernoulli equation. Alright, Bernoulli equation is the almost first order linear equation. And if you look at the equation, dy over dx plus p of xy is equal to q of x times y to the n. And you can see that here, this extra y to the n on the right hand side makes it not a first order linear equation. So, but there's a clever substitution to actually turn this into a first order linear equation, right? So here's the substitution. We're gonna let v be, right, y to the 1 minus n. So this n comes from here, right? So let's go through the derivative. So if you take the derivative, you get the dy over dx, actually dv over dx, I'm sorry, right? Then derivative would be quantity 1 minus n y to the negative n power, then multiply by dy over dx, right? So what we want to do is, so let's see, original equation have dy over dx. In order to create the dv over dx, we need to multiply by 1 minus n times y to the negative n. So what you do is take the original equation, we're going to multiply, I'm going to go down here, right? So I'm going to take this original equation and multiply by 1 minus n y to the negative n. Right? Then what you get is, of course, 1 minus n. You have y to the negative n. Right? Then we have a dy over dx. That's the original left-hand side. Right? Then you have 1 minus n. Right? And then we have a p of x here. Right? Then we're going to combine y to the negative m and the y. So it's going to be y to the 1 minus n, right? And this is equal to, right? And 1 minus n, and there's a q of x, right? But luckily, right, y to the negative n and y to the n cancel out. So you're just going to get this, right? Then you see that we see familiar expression, right? So this entire right-hand side, left-hand side is exactly the same thing as dv over dx. And what you see here is actually the original v, right? So you would end up with the equation, right? Left-hand side is exactly the same thing as dv over dx, right? So this is equal to, right? Only adjustment we have to make is a 1 minus n, right? Oh, actually, sorry, I messed it up here. Right, this is not an equation here. This is that's an addition there. All right, sorry about that. So here, and so it's a p of x and a v. And of course, I still messed up. So here, this is going to be plus here. All right, so this is equal to 1 minus n q of x. Right, 1 minus n is just going to be a number. So you can see that this is actually a first order linear equation. Right, so this is going to be the first order linear equation, right? Then we can use the integrating factor to solve this linear equation, right? So let's look at an example. All right, so the differential equation we have is x dy over dx plus 6y is equal to 3x y to the 4/3 power, right? First, we need to divide through by x. So I'm going to go ahead and do that. So we're going to divide through by x. We'll get dy over dx plus 6 over x y is equal to 3 times y to the 4/3 power. Alright, so you can see that this is a Bernoulli equation. So what we want to do is we're going to do the substitution. Let y is equal to, let's see, y to the, oh sorry, it's not y equals, v is equal to, v is equal to y to the 1 minus n. N shows up right here. So this is our n. Alright, so minus 4/3. Alright, so this is going to be just a y to the negative 1/3. Alright, then the resulting equation, let's look at this. It's going to be dv over dx plus 1 minus n times p of x v is equal to 1 minus n qx. So this is going to give us the new equation, dv over dx plus, alright, so 1 minus n would be, I'm going to actually go ahead and do it. So 1 minus n would be negative 1/3, right? And the p of x is 6 over x. Then you have a y, so it's going to be a v now. Is equal to q of x is in this case is 3, so it's going to be a 1 minus n, which is negative 1/3 times 3. Right, so let's clean up a bit. So this is going to be, right, dv over dx. Right, then we can cancel 3 and 6 and 2 left over, so it's going to be a negative 2 over x v, which is equal to simply, we can just cancel 3 and 3, negative 1. Right? So we can see that this is just a first order linear equation. So this is going to be our, p of x. And this is going to be our q of x. Right? So let's find the integrating factor. So integrating factor, so I'm going to call it I, right? So it's going to be e to the integral of p of x is a negative 2 over x dx. So this is going to be, e to the, there's a negative 2, it's just number, and the 1 over x, antiderivative is natural log of x, which is e to the natural log of x to the negative 2 power, because we can place this 2 up here. Right, then we can cancel e and natural log because they're inverses of each other. So you just get x to the negative 2. Alright, so therefore we can find v. Right, remember that the v is always going to be 1 over I. So 1 over I is x to the negative 2 power. Then integral q, which is negative 1, times I, which is x to the negative 2 dx. Alright, so this is going to be, alright, so reciprocal of reciprocal, so this is going to be just the x squared. Alright, so this is an antiderivative, so we're going to have to do, let's see, I'm going to put the bracket here, so negative 1 is still there. Antiderivative of that would be x, and add 1 to the power, so it's negative 1 over negative 1, and plus some constant c. Alright, so we have that. then we can just cancel out. So there's a -1 here and a -1 there. All right, then I'm going to distribute this x squared to the first term and the second term. So you end up getting x squared times x to the -1 would be just x, and plus c times x squared. All right, but to remember that the v in this case is originally y to the -1/3 power. So this is equal to x plus c times x squared. All right, then we can just raise both sides to, I have to negate that -3 power. All right, so y is going to be equal to, so it's a negative power would be a reciprocal, so I'm going to go ahead and take the reciprocal, but we're going to just raise it to the third power, so x plus c x squared, raise it to the third power. All right, so that's the solution of the original Bernoulli equation. All right, so I'm going to just box it out. All right, that's it. I hope that this was clear.